1 kilometer. This is our goal for Hadron, our most ambitious rocket yet and our entry in this category. Everything we learned from Quark 2 went on this rocket. Here's what changed and why. For the Hadron mission, we are scaling up the flight-proven framework of Quark 2, using the semi-optimized fiberglass layup and machine aluminum couplers, validate with a 100 times safety factor. To meet the higher performance demands of this vehicle, we add tip-to-tip fiberglass reinforcement of fins. This increases stiffness and prevents our LASC flutter. And that brings us to the aerodynamic choices that shape this rocket.
The Hadron features an LED hack nose cone to minimize drag at its highest operational speeds, along with a conical boat tail and trapezoidal fins with an ACA 0011 profile. And to reach that altitude, we need a propulsion system that can deliver the right impulse at the right time.
The Hadron propulsion system is built around a motor operating with 6 KNSB grains featuring a base geometry. These grains are warped in paper to provide thermal protection for the 6063 T6 aluminum casing. Its peak pressure of 4 MPa resulted in a conical nozzle with a throat diameter of 14.1 mm and expansion ratio of 6.5, yielding an exit diameter of 36 mm. The motor burns for 1.26 seconds, delivering an average thrust of 693 newtons with a total impulse of 960 newton seconds and a specific impulse of 131 seconds. The bulkhead was designed with a thickness of 4.85 mm and is coupled via 3 M3 screws at the top.
For the Hadron mission, our avionics architecture consists of 5 main subsystems designed for maximum reliability.
Taking advantage of the large internal volume for an optimized layout, we use a SP32S3 dev kit as the main microcontroller. This manages flight events with a regulated power distribution unit capable of delivering the necessary current to fire the recovery scheme. An LoRa telemetry module communicating with our custom ground station for tracking and data analysis. The 50 PCB ensures absolute ejection safety, providing full redundancy for recovery activation through a completely independent altimeter with its own isolated power supply. And it's that recovery system that will bring Hadron safely to the ground.
Hadron's recovery system is centered around a custom-designed pyrotechnic ejector. A black powder-driven, pressurized cylinder that forces a piston to deploy the parachute precisely at the apogee. The ejector fires through a dual-channel ignition system, a primary and a redundant igniter wired independently, so even in the event of a single-channel failure, deployment is guaranteed, thanks to 2 completely separate electronic systems. The black powder charge is housed inside a custom-treated bolt that screws directly into piston, hermetically sealing the charge and securing zero leakage before ignition. The parachute is a semi-elliptical canopy of 122 cm in diameter, with a vent hole of 16% on its nominal diameter, delivering a stable, oscillation-free descent and bringing Hadron down to a safe landing speed of 7 meters per second.
Every system optimized, every component validated, every grain accounted for. We built Hadron, 1 kilometer straight up, and on September it flies. See you at LASC.